Hello, so we continue here with our calculations. So we are going to look at the general formula as we agreed on in the previous video. Yeah, so the general formula or the general rule actually emerges from the same principle, from the same first principle of differentiation actually. So we have this formula: y is equals to ax raised to power n. And those examples we had, the first one, we were actually asked to differentiate using the first principle with the given function f of x equals to 2x. So this, the formula that we are using for differentiating, it was emerging from this function. We have your a here and n, which are constant, where a is 2, your x is your x here, and n here it is 1, because x, it has the power of 1. We can write your 1 here, or you can just leave it the way it is. If you want, you can write 2x raised to power 1. So x here, it has the power of 1. Any whole number or variable which doesn't have a power, it simply means it's carrying a power of 1. Those are the rules of mathematics. Okay, so we continue now the general formula. So the general formula or the general rule, if y is equals to ax raised to power n, then dy dx, then dy dx is equals to a, which is constant, nx raised to power n minus 1. So this is the general rule or the general formula that we're going to be using to differentiate. So this rule states that, for example, you've been asked this question. If you've been asked actually to differentiate your 2x using the general formula, x here, it has the power of 1. X here, it has the power of 1. You multiply that power which you have times this base here, which is 2x. This is what it was done here. Your n here, which is the power, it was being multiplied with the base here, which is ax, which is when you come on top here, which is ax. So your n here was being multiplied with the base here, which is ax, and they got anx. Then what do you do to the power? The power here, you subtract minus 1. This is what was done here, minus 1. So we're going to do the same thing as well. So you have your 2x here. What is the power of x? Remember that x, it is the one which is carrying the power. That variable, it is the one carries the power, not the number. That's the mistake those are the common mistakes that we do make. If you've been given you have 2a, you have 2x raised to power 2, or you have 2x squared, you think as if 2 is also carrying that square. No. X, it is the one which is carrying that power, not the coefficient. I hope it's clear. So we start. X, it has the power of 1. You multiply that power of 1 times this base, everything here. So it will be 1 times 2x. Your answer will give you 2x. Then what do you do to the power here? You substitute minus 1. You subtract minus 1, not substitute, so but subtract. You subtract minus 1. So that power, the power of 1 here that we have, we subtract minus 1. So I'm just going to show it here. So it will be 1, which is the power of x. What do? We subtract minus 1. Next stage. So it will be 2x. What is 1 minus 1? 0. Remember that x, it is the one which is carrying the 0. Not 2, no. But x, it is the one which is carrying the 0. What's the next step? This one, you sort out this. So you write your 2 here. What is x raised to power 0? The rules of mathematics states that the rules of indices. Any number raised to power 0 is 1. Any variable raised to power 0 is 1. Anything that is raised to power 0, it's 1. Yourself raised to power 0, it's 1. I think that's clear. Even 1000 raised to power 0, that's 1. So it will be 2, open bracket, what is our x? 1. So equals to, what is 2 times 1? That's 2. So therefore dy dx is equals to 2. So if we look at the differentiation part using the first principle for the function, the f of x is equals to 2x. In our previous video, actually, the answer, it was the same. It was coming out as 2x. Let me just take you back. Okay, so differential calculus. So we were using the first principle. So this was the formula that we were using. The lim as h approaches 0 equals to f x plus h in bracket minus the f of x over h. So we had this question here. The f of x is equals to 2x. We had these solutions here, calculations. The dy dx equals to the lim as h approaches 0 at the f of x plus h in brackets minus the f of x over h. It was this one. When we substituted, we had this. Then once we substituted, we had to do the expansion and the subtraction. So our final answer, actually, it was coming out to be this one here. This was our final answer here, 2. dy dx equals to 2. Okay, so let's proceed to the next level. So to the next question, sorry. Okay, so let's try by all means to be remembering these things. Okay, so this was the first question. We go to the second one. Okay, so the second question, let's try to solve. Let's try to solve the same question that we were asked, actually, to do what in the first principle, like using the first principle. The same question we solved using the first principle, let's solve it actually using what? The general rule, if we're going to find the same answer. So question 2, it was question 2 here. It was the f of x is equals to 1 over x. Let's solve it if we're going to find the same answer we found in the previous video. Okay, using the first principles. But here we are solving this one using the general rule, whereby you have your dy dx is equals to anx raised to power n minus 1. This is the general rule that we are using. So what are we going to do? Okay, so what we are going to do is, this, we've been asked actually to differentiate this one. How are you going to differentiate this one? It is 1 over x. Though the rules of indices states that if you have one bar, I'm going back to the rules of indices. No wonder I was telling you that in the previous video. Like each and every part of mathematics, it is connected. Algebra, indices, those integers that we learned back then, they're all connected. Mathematics, just the build up of each and every basic topic you learned. Okay, so now you have this one. If you have one bar, this one is the bar, or I'll use the over, the one we're familiar with. 1 over x. The 1 over here in math, it simply means it is negative 1 as a power. This one as a power. Negative 1 as a power here. If you have 1 raised to power negative 1, if you have 1 raised to power negative 1, it simply means you have 1 over, meaning this one, the negative 1 as a power, that is 1 over. Then you bring your 1 here. So which is 1 into 1, that's 1. So meaning 1 raised to power negative 1, that's 1. This is mathematics, guys. 1 raised to power negative 1, which is 1. Okay, so here if you have 1 over x, here when you rewrite it, which means you're going to have x, it is the same as in x raised to power negative 1. I think we're together, guys. So we have x raised to power negative 1. Then you solve this one now. This is the power. What did you do? The power, it multiplies with the base given. So this is the power, it multiplies with the base, which is x. So what is negative 1 times x? You're going to have negative x. Then the power, you subtract minus 1, so it will be negative 1 minus 1. I'm going step by step. I don't want to miss a step, so that at least you are supposed to be following as well. Okay, you have this one. What is the next step? This is the next step. Okay, so you have your negative x here. You write your negative x. What is negative 1 minus 1? If you have a negative and negative, the rules of integers. If you have a negative and a negative, what do? You add, you get the sign of the bigger number. What is 1 plus 1? That's 2. Which one is big here? They are all equal. So just pick any sign, because the sign are just the same. So it will be negative what? What is 1 plus 1? That's 2. So it will be negative 2. You have something like this. What do? The next step, negative x raised to power negative 2. We go back to this. You get, because the rules of mathematics, when you're dealing with differentiation, you are supposed to leave your answer in positive form, not the way it is in negative. You can end here, but you're going to have low marks. Like if it is 5 marks, they're going to give you even a 4 out of 5. If you are lucky, if you find a mark actually has a heart, they can give you 5 out of 5, but let's try by all means to leave our answer in positive forms. Okay, so here you have your negative x raised to power negative 2. What do? This negative here, it is a bar, so it will be 1 over, this is the negative part here, it is 1 over, then you get your negative x here, it comes down here, then raised to power 2. I hope this is clear, guys. You have negative x raised to power negative 2. This negative part, it is the bar. This is the 1 over. As long as you have a power as a negative, becomes a bar. This is a bar. 1 over. This is the negative part. So x to be raised to power negative. So to be x raised to power 2 down here. So you get your negative. Since x it is carrying a negative, to be negative x raised to power 2. You have this one. So this becomes your final answer.